Welcome to the DIY Honda Garage channel. The DTC P0A11 indicates a malfunction in the DC-DC converter activation circuit for the Honda CR-V 2023 and later models. This diagnostic trouble code is stored when the powertrain control module, PCM, cannot receive a boost demand notification from the DC-DC converter. The DC-DC converter is crucial for converting high-voltage DC power from the battery into low-voltage DC power to supply vehicle electrical systems. The PCM is the central computer responsible for managing engine and transmission functions and ensuring that various components work together efficiently. In this case, the issue lies in the communication between the PCM and the DC-DC converter. And if left unaddressed, it can lead to further electrical system malfunctions or decreased vehicle performance. The malfunction could result in warning lights or reduced functionality of electrical components, signaling the need for diagnostics. The DTC P0A11 indicates issues related to the DC-DC converter and the PCM. The DC-DC converter is an essential component located typically near the vehicle's battery or high-voltage systems, responsible for transforming high-voltage electricity into a usable low-voltage form for components like headlights and the infotainment system. The PCM, which manages various vehicle functions, must receive a boost demand notification from the DC-DC converter to function correctly. If that notification fails, the PCM stores DTC P0A11, indicating a malfunction within the activation circuit of the DC-DC converter. This malfunction could stem from wiring issues, a failure within the converter, or a problem with the PCM itself, potentially disrupting the vehicle's power management systems and creating electrical system inefficiencies. Several factors can lead to the DTC P0A11 being triggered. First, wiring issues, including open or short circuits in the DC-DC converter activation circuit, can prevent proper communication between the components. This can result in the PCM not receiving the necessary boost demand notification. Second, the DC-DC converter itself may be faulty. If it cannot operate as designed, it won't send the required signals to the PCM. Lastly, the issue might lie within the powertrain control module. If the PCM is malfunctioning, it might fail to interpret the signals from the DC-DC converter, storing the DTC without any faults present in the converter. Therefore, diagnosing requires a systematic check of these components to determine the root cause effectively. The symptoms of DTC P0A11 can manifest in several ways. Drivers may notice warning lights on the dashboard, indicating issues with the electrical system or hybrid performance. Additionally, there may be decreased functionality or performance of electrical components, which relies on the DC-DC converter for power. Users might experience issues such as dimming lights, unresponsive infotainment systems, or problems with auxiliary battery-powered systems. In more severe cases, these symptoms may lead to overall vehicle operating issues, including warning messages or reduced hybrid efficiency. It's crucial to address these symptoms promptly to avoid further complications or potential drivability issues. Proper diagnostics will help identify if the symptoms directly relate to the DTC P0A11 or if other issues might be present. The first step in troubleshooting DTC P0A11 is to conduct an initial test drive of the vehicle. Focus on ensuring that the vehicle operates normally and does not exhibit any immediate symptoms relating to electrical issues. After a satisfactory drive, employ the auto idle stop function to shut off the engine. This action is crucial as it allows the system to reset and determine whether the DTC reappears after the vehicle has been in a powered state. If the DTC resurfaces post-idle stop, it confirms that the initial condition hasn't resolved and points towards the potential malfunction within the DC-DC converter or its circuit. This step lays the foundation for further detailed diagnostics in the subsequent troubleshooting phases. In the second step of troubleshooting, it's essential to prepare by disconnecting specific components. Start by disconnecting DC-DC converter connector A, which usually has 3 pins, and PCM connector A, which typically has 50 pins. Ensure that power to the vehicle is off before handling these connections to avoid electrical shorts or damage. Disconnecting these connectors allows for direct testing of each component's integrity without interference from the vehicle's systems. This preparation step is crucial for accurately assessing the health of both the DC-DC converter and the PCM, helping to isolate faults within the activation circuit and ensuring a thorough next step in the diagnostic procedure. The third step involves inspecting the DC-STS, DC-DC status, open wire condition. Using a multimeter, check for resistance between the terminals in the disconnected condition. A reading of less than 1 ohm indicates that the circuit is intact and functioning correctly. If the resistance test indicates an open circuit, the wiring may be damaged or faulty, requiring further inspection and potential repair. This step helps ascertain if there are any breaks in the wire leading from the DC-DC converter to the PCM. Properly conducting this inspection is critical, as it can reveal both immediate issues and potential problems that may cause future DTCs, thus ensuring more prolonged operational reliability of the vehicle's electrical systems. The fourth step involves checking for any short circuits within the DC-STS wiring. Set the multimeter to the continuity test mode and check if the circuit is shorted to power with the ignition turned on. If the wiring is found to be shorted, it suggests a severe electrical fault that must be rectified before further system tests. Conversely, if no short is detected, the circuit integrity is confirmed at this stage. Any indication of a wiring short not only explains the DTC condition, but also presents an urgent need for repairs to prevent component failure further down the line. Therefore, addressing this issue significantly affects the overall functionality of the DC-DC converter and the vehicle's electrical systems. In the fifth troubleshooting step, it is essential to replace the suspected faulty DC-DC converter with a known good unit. This is a common practice in automotive diagnostics, where direct testing of the converter may not be feasible due to its design limitations. Install the substitute component and attempt to replicate the failure conditions that initially triggered DTC P0A11. If the fault persists, it indicates that the issue lies elsewhere, possibly related to the PCM or other components in the electrical circuit. However, if the DTC clears after the replacement, it confirms that the original DC-DC converter was indeed the source of the malfunction. This diagnostic approach not only streamlines troubleshooting, but also narrows down potential causes, ensuring an efficient resolution to the problem. The sixth step is to confirm the functionality of the powertrain control module. If the previous steps have suggested that the DC-DC converter is in good working order, yet the DTC remains, focus shifts to the PCM. It is designed to control multiple vehicle functions and receives inputs from various sensors. If the PCM itself is malfunctioning, it will not process information correctly or communicate with the DC-DC converter, subsequently storing error codes without a genuine fault in either the converter or the wiring. At this stage, using specialized diagnostic tools can help ensure that the PCM operates correctly, allowing for a thorough assessment. If necessary, this step may lead to PCM replacement to restore full vehicle functionality and rectify the error. After completing repairs for DTC P0A11, the final repair verification process is essential. Begin by clearing the DTC using the vehicle's diagnostic tools. Once the trouble code is cleared, conduct another test drive of the vehicle to monitor its performance closely. During this drive, observe if any warning lights reappear or if the vehicle exhibits any symptoms related to the previous issues. This step is crucial as it helps confirm that the initial malfunction has been resolved effectively. If the DTC remains cleared after several driving cycles, the repairs can be considered successful. Ultimately, this verification not only ensures the immediate success of the repair, but contributes to the long-term reliability of the vehicle's electrical systems. Preventive maintenance is key to avoiding future occurrences of DTC P0A11. Regular inspections of the DC-DC converter, wiring, and connections can catch potential issues before they escalate. Keeping an eye on electrical systems, like lighting and infotainment, also helps to identify problems early on. This vigilance ensures that any irregularities are addressed promptly, preventing disturbances that could lead to error codes. Following manufacturer recommendations for servicing and troubleshooting will enhance the reliability of the vehicle. By prioritizing these inspections and being proactive, owners can significantly extend the life of their vehicle's electrical components and prevent serious breakdowns. In conclusion, understanding the significance of DTC P0A11 is vital for maintaining the Honda CR-V 2023 and beyond models. This code indicates problems with the DC-DC converter activation circuit, and prompt troubleshooting is essential for effective repairs. Following the systematic troubleshooting steps, from initial inspections to replacing faulty components, ensures that all possible causes are adequately addressed. Moreover, preventive maintenance plays a crucial role in extending the life of electrical systems, reducing the likelihood of encountering this DTC in the future. Finally, being informed and proactive enables drivers to enjoy uninterrupted vehicle performance and enhances safety on the road. Please like and subscribe to the channel. See you next time.